hello everyone, thank you all for watching. Today it took a little bit longer than usual because we are setting up TikTok live. We have a lot of people joining, more than 50. So far we have 112 people looking at this thing. That is amazing. Today we will learn Houdini for Unreal for games. We are attending DoubleJump Academy's workshop. This is day 19 and we are kicking. That is awesome so far. We have a lot of people watching on different platforms. This thing is getting bigger and we are getting more attention, which is awesome. It's exactly what we need. We need more people to see the progress of learning. Okay, so Houdini and Unreal. Let's learn some more. Good. Let's pause the recording. So far we haven't changed much. We just added for each and basically access the metadata of that for each so we can enable the iteration and do different things with it. And what we will do now is add the grouping the same way we were reading about them inside of the documentation. And if I might show you, it's right there, those things, the render, collision, geo, the things that we were explaining in the last episode or yesterday basically in the stream. The UCX stuff as well that basically enable us to split them, and we will see what that means and how could this whole thing work. The splitting yesterday we stopped right there because we were reading through it. Let me just remember what UCX means. I will just go for finding it in the page. So here you go, collision, geo, UCX. All right, what does that mean? To use these, which these? So simplified collision geometries are important for optimizing collision detection in game. We read this yesterday, and I think this thing creates a convex hull and it generates a simple collider in Unreal. Those colliders will use a default collision complexity. I think that is one of the easiest way to create collisions and basically let Unreal define their resolution. You have multi here for different resolution, I suppose, but for now we will probably name our current collision geometry collision geo UCX. We can also go with render geo UCX to see it, to be able to see the collision, but for now we'll go with collision geo UCX. So let's do that. We will add a group right there. So tap and we'll add a group in here right there. All right, and we will name that group collision geo UCX because we want Unreal to generate one for us. So far so good. Let's also name the group itself, not only the group name but the group node to the same name, so we will be able to easily understand what is going on. All right, so that is good for now. Let's pause the video and we'll... Okay, so basically we could see the fruits of our labor. We could see that collision geo UCX has basically made a group for some of the pieces. And the pieces, what are those pieces? Where are they coming from? If I go here, there is a node called the name. The name should have, or the segments, one of them is no, wait. Before that, right here, we have segments and it's an integer. Let's check that attribute. It is a primitive attribute, I think. Surface. No, that's the name. Let's see details. Point number PPP. Let's check our convex. Wait, where are we getting our data from? I think from the class it's splitting them. All right, so if I now enable single pass, let's enable it and go by each pass, it should more or less... Now wait, let's click on this one, I think, and now with the single pass we're seeing the different pieces we're working with. And let's view this one and template this one, and I'll show you those pieces now, how it had simplified them for us. So if I run through them, there's absolutely more than 7. There's 19 because it's actually, it says there are 10 pieces. That's funny. Oh, is it though? I think there are more pieces. Yeah, okay. The reason it was showing us piece 10 here is because when we added the single pass, it was adding the single pass there as well. So it was calling in the pieces names. And that is coming from the connectivity. The connectivity is adding to the different pieces a certain class, and that class is working with us now to define those pieces. Okay, good. So far we have learned that, and we created a group for each of them now. That is what we have done so far. All right, let's check what else we could do. We will basically now make a smart group naming. So we will name each piece and give each piece a number, and we will see how that will work as we go. Okay, so one by one, people. We will go one by one and check what we are learning here. And all right, so let's go and learn some more. So first of all, we need to get the iteration inside of the grouping. Let's enable that. So how to do this? We need a spare input. So we did that before, actually, so it's not that hard. Add spare input. Right on that ranch icon, we go add spare input right there. Click on that, and now you have an add spare input. That spare input will be right there. And now in the spare input, you will be able more or less to get your iteration into it. So how to do that? Click on the grouping. You have the spare input right there. Drag and drop it right there. And now we have our spare input. And we actually have the reference to that in a line right there. That is awesome. Cool. So that means we could do that. So how to make the smart group naming? In order to add an expression in the naming, you have to add this type of letter. I don't remember what it's called. It's right above the tab key. Okay, so you add that one, and then you start the same way we were starting before. So first we go to the detail. Why detail? You're asking because the iteration attribute lives in the detail. So first you need to call where you're pulling things from. Okay, so we'll just put this thing back. Okay, so where are we pulling things from? Not from our butts. So if I go into the detail, we see iteration number right here. And that iteration number will go as the loop goes. Goes 1, first loop, 2, second loop, third, 4, 5. It will go into the iteration. It says 19 right now. And so we have a for each end, correct? And the for each end, we have our single pass. All right, so that is, we don't need that. Let's go back to our grouping. We were writing an expression. And we started with detail the same way we're starting with the different things. Okay, so we add 2 columns as we're used to. First of all, where is this input coming from? So 1 means the first input. Second means the second input. 0 means inside of the node. -1 means spare input. So we learned that so far. So we start with that, -1. All right, what is the next thing? What is the attribute you want to access? All right, we put between 2 quotes, we add our iteration, and we hope that we have actually spelled it right. Let's spell check that. And here we have iteration with 1 T. Always spell check if you are not sure. Iteration, we have it right there. All right, what index number? 0. Why? I still don't know why. But this basically should now give us... if we add here, did they add it? Did they add like a space or not? Let me just check on that real quick. I might add a space, I'm not sure, but this will basically add a smart way to name the group, right? It will smart name it, and it will be by the name of the number of the iteration. So it will say collision GOUCX number, right? We could actually even... All right, let's... I don't want to go too deep because I'm not too sure, so don't quote me on that stuff. We'll pause the recording. We'll be right back with you. This thing went really fast, so let's check if everything is working. Let's check if we're getting any errors. No errors so far. Okay, so let's hook that thing up with the output, and the output comes right there. So hook it up. Boom, it is hooked now. Let's press Shift S to have a nice smoother lines in here. That is amazing. Okay, cool. What is the error here? Let me check on that. What are we getting? It says geometry has been converted to quads and triangles. Have it really though? We might actually... That might actually be the case because of the box. Let's see the difference between box geometry. It says quadrilaterals. That's hard to say. Same polygon mesh. Nothing else is happening. No extra sugar. Good. Let's keep going to the next thing. We will probably merge things here. before that one. So let's take that output right there. And we will merge things inside of here. Let's merge our collision with our Unreal Logic. Let's see if that make things work. And then we will test and see if things are working. All right, so the merge looks like this. Doesn't look super bad. Yeah, let's keep it like this. I feel like this is too crashing into each other, but we will see about that later. All right, so this is our box. This is our collision, this one. We probably need to give it a auto UV. Let's see if things worked for them in the course, and we'll be right back. Basically, what I noticed is that this thing is right in line with the cube, and I think that is causing some issues. So I will add some size in the x-axis, I think. That is, no, that's cluster size. Wait, where are we clicking, guys? All right, so let's see. The size in here should change. Not this one maybe. 0.01. Let's check. Yeah, exactly. That is the type of effect we want. So let's go inside of here. And now we will wait because it has to do all those weird calculations that we let it to do. So we'll wait a little bit. And we're waiting, and here we are. We're right back into it, and we should have better geometry that is not colliding. All right, so yeah, we don't have colliding geometry anymore. Let's check how this thing will work in a second. That it won't work for him because watch a little bit further in the video, and one of the mistakes that they realized was that the grouping here needed, or when we've added this, right? So what is the out result of this? It is not the actual geometry as well. So we need to hook the actual geometry inside of the merge as well. So inside of here. So right now it's just collision geometry, and we needed the actual geometry as well. And so this will hopefully make things work. And let's see for ourselves. So we will save that node. Right, so right click, save node type. Amazing, good. Let's minus that. Let's go inside of here. We have a Houdini session. Let's go into our HDA right there and right click on that thingy. And then we'll say rebuild all instances. And we will have the thing now rebuilding all the instances. And will take some time, but we should have everything back where they are. Cube, let's enable that, and now things are not showing up, and that is due to the addition of the fraction region. So what we'll do is copy that cube, paste it again, and now we have cube 2. And first of all, get our HDA to communicate with the cube. That is fine. It is fraction shape is getting the world input. That should be working. Now what we should add is the second cube, which is right there, and we'll make that thing a bit bigger. Like right there, a bit bigger like this, and we will make it interact with the HDA. Okay, and that should basically give us the ability. Well, first of all, let's see if the thing is working anyway. So what we will do is, since we re-imported the thing, we will give it a scatter amount of 202. We will press enter, let it cook. It says finish cooking with errors. So we have some errors, definitely. That is why the thing is not showing. Let's check what the errors are, and we'll be right back. Let's take our mesh from the split. Maybe the group thing had broke things up. Not sure completely, honestly. It says here that we have a mismatch of attributes, but he's also getting an error there. But I'm not sure if he's getting the error inside of here. Geometry has been converted to quads and triangles. I think we might have changed something here before that had changed some other stuff. Let me check polygons. Polygon soap. Yeah, I think we've changed it here, but it should be a polygon in here. But I'm not sure if he has the same error here. Let me check for that. I'm slowly trying to basically fix the problems we're having, and I'm trying to understand the setup again. I think yesterday we rushed through it because I didn't have time at the end and I wasn't feeling it that much. So we have the unpack here, and that it's completely wrong. It should be right after the group active. And basically, not only that, but it should go into UV after the unpack. right there. And then in the UV output, we output it to split. And now we could split it pretty neatly, so to speak. So we unpacked it again. So we are working with primitives and no, so we're working with the pieces again like we did before. And in the pack, we have changed them to basically call out the group active and nothing more. We just did this split to make this work. So what I will do is basically put all this work here because it basically belongs there. I'll put the group on the right. I'll put this pack on the left as well, just to see that we did like a little thing just to get the group active, right? And then we have the unpack to get it back to normal values. And then the UV again, which should show us the UV if I press W. Here we go. And then I have the split. And the split looks like that. All right, so let's see if what type. All right, so the split is not working anymore because we need the proper grouping and we need to make sure that the proper grouping is working. And also allow me to check if that structure is correct. All right, I figured it out. It's just a second of one input that we had to change. You see here, there's something called transfer groups. In the transfer groups, you could allow it to transfer active. What I noticed so far is that we had the group here. It was actually working. It was saying point groups and it was giving it. And once it goes here, it's gone. And I was actually fooled by the inside and outside here because they are not the groups that we needed. So we need to transfer the group active. And this should basically take it into here. Here we have it. It's passing through it because the unpack basically changes a lot of the attributes, I think. So we have to keep that in mind. And now with the split, we should be able to split those things. This one should be only the active. So let me choose it first. All the way down. Here it is. That's the active. That's the one we want to break, right? The one we want to keep static is this one. The inside of the wall. That is the wall of the building that's connected to the columns and everything, and it won't break because maybe the bullet didn't make it so far. That is why we're having parts of it not working. We want those parts to not work on purpose. As for the inactive grouping here, I will delete. And what I will do is hook this to the null here just to stay organized. And basically also the null should emerge again. And this we will delete. We have our collision parts here. Let's see if all is working. Okay, let's see. First of all, here we have it. It is working. We don't get the error anymore. I think we were getting it because of the wrong structure of our nodes. We should have just paid a bit more attention on that. But yeah, I was tired yesterday. It's fine. Now we know how to do it. And we have a merge. Let's actually have that merge enabled. And let's get our Unreal Logic inside of here. Let's put our Unreal Logic next to these guys. And take this one down here. And then basically hook the merge inside of here. The merge is hooking everything else. The output looks like this. It's unfortunately not taking the UV with it, although it should here. We'll take our explosion value a bit higher just to see what will explode here. And we should look into our explosion. All right, our explode view. This looks cool. It's completely... It's very interesting. I think we missed a point or two. That is why we need to check it again. Maybe the value here is just too extreme, honestly. Let's hide the points. And we see that there are some points from here going outside, although this should be quite static. Yeah, there's something not working. And the collision is also exploding with it. Let's see, let's look into the tutorial. We'll be right back. I think we have our setting honestly all set up correctly now. I think the only setting I've seen that we missed is the unpack and the structure here as well. I think that was not correct at all. What we need to make this work now, where is this going all the way there? We don't need that connection. So at all, like, thank you. Now we have our UV going, splitting the two geometries. One that is doing this, which is the active, which should break, and the one from inactive, giving it an actual collision. Now, I started to understand why we're making the collision. So the collision is containing those parts, and we see how that is not working right now in Houdini because it doesn't understand those collision values. We see everything is exploding regardless. And if I continue to make this value bigger, you can see that the collision is here not changing its value. And that is exactly what we wanted to do. We wanted to cut the values inside and keep it in that cage, which is a collision cage. And those pieces will not explode. So we're splitting them in that way. We have made them way less in the resolution, and we've kept that collision inside. We might, at one point, need the collision to break, and this will give us another layer of simulation in Unreal, I think. That is my current understanding. You can correct me if I'm wrong, of course. But yeah, we will just continue further now. I'll try to save this and import it into Unreal and check if we still have the baking errors. The backhoe had worked so far. Now it's time to check the next steps and see where we can go from here. And we will start doing some stuff blindly now just to learn, and we will document the thing as we go. So since in Houdini we have added an input and we called that input fraction region, we should also do the same thing in Unreal. If we go down a little bit into our fraction region input, inside of Houdini inputs, we can choose world input. And this is pretty awesome, because now we could copy the cube and paste it again, position it as such, give it a bigger scale in one axis only, on two axes, sorry. All right, and that should represent our fracture region. Awesome. Now let's work on that. I will also expand it this way. And back to our actual HDA, we will start selection, select our cube, and use current. This should now be able to give us that value. Okay, so let's hide our cubes. Good stuff. And let's also make sure some type of, I think there will be some collision happening with our cube, but all right, so what we're gonna do now is add a value here that will inside of our output log. I think we looked into that yesterday. We could also limit our FPX like one of the YouTuber has actually showed us how to do yesterday on the comments, but I have completely forgotten how to do it. Give me a break. I'll check the stream from yesterday and let you know how to do it. Look at that. I just wrote it from memory and it actually given me the value. So if I limit our FPS to 24, this will improve our performance for both the stream and the actual simulation. So that's pretty awesome. And now from the course itself, we will learn how to basically add how to show the collisions from the region here, because as you can see, collisions are not visible right now. So there's a way to put it in the output log where you could enable the collisions. Now let me check that and I'll be right back with you. All right, those commands are actually simpler than I thought they would be, so that's quite cool. And I'm sorry for not showing it to you before. I'll do it right now. I completely lost track of the... All right, so you go back to the output log right there, and then you write, like we did before, t.max FPS, and now we could change it to whatever FPS we want. And now it's actually just telling us what the value is. If you don't put 24 or any number after it, it would just tell you what is the current thing set for. That's cool. Now the next thing we will add is show collisions. Show collision right there, and basically we will add 1 for true because it's a bool value, and we are able to see our collisions in the actual game. In Unreal, we have collisions everywhere, also including a collision into where we have decided to put our collision into, with the loop operation and everything else. So now it has a collision on each and every part, right? Time for some simulation. I will basically just save all and be right back with you. I hope it doesn't crash. All right, moment of truth and play. Let's see if we will fail. Yeah, that is cool. That's kind of cool. It's basically fracturing that side and keeping everything else inside of here inside of our setup collision that we've made using the UCX method, which allows Unreal to do it automatically. All right, now let's see if we can break that thing. If we can break it by... Yeah, we can't break that thing, I think. Let's see. Let's put this thing here and try to break it. Yeah, it's a wall, right? And I think there is a way where we could make this thing break eventually by hitting it with more bullets, for example, or having explosives. So, for example, we can have that part of it be broken by bullets, right? And the other part with the collisions can be only broken by explosive, for example. We can have it work like that, I guess. Let's keep going. For now, we set it up, and yeah, let's keep learning. Good. But basically what we've learned so far is that there are ways to do that in Unreal Engine as well. So let's look at that, how that's done, and see what is the difference between Unreal Engine and what the workflow we've been working in is. So if I go to, actually, let's add a cube, right? Let's add a sphere, then whatever it is. So shapes, sphere, right? So we have a sphere right here. Let's make it a little bigger. Okay, so that is our cool sphere. It's right there. Let's look into it. And what we could do is go into our fracture mode right there. And now we'll show you some cool tricks. Inside of Unreal, you can start the uniform operation, and this should basically give us now some parameters to work with. So let's see what those parameters can do. Let's just put this thing here and look into those parameters one by one. So fracture level, we have one level. Explosion level, that is something we've been working with before. Minimum Versanoi, let's see, let's go with 100. Let's go with like 50 here and 500 here. And let's go automatic. Let's see what else is there to be done. I'm not sure if it works on a sphere. I'll be right back, actually. All right, so that was the thing that I was missing. So you basically have to create a geometry. It's called generate a new geometry connection asset. That is something we actually did in Houdini as well. The geometry collection, if you remember, the GC, that's something we had to add manually. So let's add it now, create new, give it a name. We're just gonna call it test. I think we're looking into something, right? The sphere, all right, create geometry collection. Here it has its own, all right, it crashed. Well, that's amazing. That's why you don't use that. Okay, yeah, all right, it crashed. I'll be right back. Good, so I made a whole new map. It's called like a whole new level. So it's like a scene in Unity, if you're familiar with that. So we'll add a new one. Just create it, wait for it, and okay. And now we'll fracture it with a uniform. Here we go, it's generating it for us. We can see that it's breaking stuff already. That's amazing. Let's fracture that. Actually, let's change some of the values. This is the maximum value. Let's go with a 500 maybe. Here you go. So now we have between minimum and maximum amount of fracture. And we can fracture it. And it's creating for us all the different attributes. Same thing like we've had before in the name as well. The same way Houdini does it. And now we could see that thing explode as we change the explode amount right there. So it's exploding for us. Cool. So we can basically add this ability as well in Unreal automatically. Let's see if it does it on other shapes as well, or if it has like a some type of weakness here or there. So sphere. Let's make that sphere big. I would love to actually explore that a bit further with y'all later. It's kind of cool that it can do that. Hi Zahur, how's it going? Let's go to fracture level, explode amount. Let's see, and U1 will create a new geometry input right there, our geometry collection. And yeah, here it is. It's splitting things up for us. It's pretty cool. Let's actually fracture that. Awesome. Boom, it's fractured. Good. So the thing is working. That's quite cool. All right, a lot of hey, how's it going? How's life? How's life so? Nice to see you here. It's been a long time since we met. So yeah, we have everything here. This will end up in the recording, but I don't mind that. It's quite cool. Let's see if we increase that minimum to actually decrease it, because it might give us a different value. Let's fracture that again. Yeah, do we have smaller pieces? What happens if I put it on a bigger number, like 200, and fracture that? Will it have less pieces or more pieces? Whoa, so that's cool. We're actually fracturing part of the fracture itself. That's quite awesome. That's really cool. But what happens if I just... But that's kind of confusing, honestly. All good. Miss you so much. You look handsome. Thank you. Let's do a Seaman. I don't know if you remember that. It's quite old. Nice to have you here. Nice to have you here. Generally, nice to have you again. Just talk to you again. Cool. Yeah, so this thing works like that. That's awesome. And let's pause this into the recording. I'm pretty lost right now because I need to go back into our scene. So, but I remember there was a way where I could actually categorize that. Custom filters. I can create a custom filter, I think. Label, make it orange. Good. Filter label string. All right, and we don't need that. Let's see if we can filter things a bit differently. Let's go back to selection mode, because it's just a bit better on the eye. First person, input maps. It's in the maps right there. All right, so don't save anything we've done here. And I would like to add a sphere again and fracture that again. All right, so let's do this. We learned how to do it now. Shapes and sphere. Here we go. That sphere is right there. Let's make it quite bigger and let's fracture. That's not big enough, honestly. Let's put it down. Oh my god, the thing is already laggy. Or maybe the mouse has lost its battery, actually. All right, now let's basically fracture that. We did it before. Excuse me. Let's go to fracture. Let's see if we'll do it without any issues. So far so good. So far so good. Let's go into fracture. And yeah, let's not explode it yet. Let's keep it like this and give it a simulation. Let's see if it will break. Good. For now it didn't break. Maybe with a force it will break. So let's check it out. Here's a cube running to you. Boom, 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 boom. Okay, so maybe because we haven't fractured it yet. So let's make it work. All right, so fracture. Let's go into uniform settings again and fracture it. All right, explosion value back to 0. And maybe we could create a cluster. So let's create a cluster. It will take some time. Might crash. Let's check it out. Anyway, it didn't crash. That's good. Let's play. That's cool. We have... Whoa! All right, that's kind of cool. It's because of the gravity so far. And if I take that cube and smash it like that into it, good. So, we've been told that this system is good. It could work for simple stuff, but it's unmatched to what we could do and the amount of control we have in Houdini. I would love to explore this a little more with Unreal, honestly, because I just love how fast it works, right? This is awesome. This is pretty cool. I really like that it's so fast that it fractures them on the go. This program, this engine is just insane, right? It should be illegal. All right, so let's pause that. This is a pretty much not ideal for fraction, especially for concrete. This is not how things break apart. Everything, as if we zoom in here, we see equal spacing almost of all those pieces. And the way concrete breaks or stuff break in reality, they have unequal pieces of fractions. So what do I mean by that? So if I take a screenshot of this, allow me to, yeah, here we go. We're taking a screenshot. If I go through it again, we have basically, these are super straight lines and they are very equal to each other's, right? Here, 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 here. You see how this is like one size, sizing everything, and it is a very repeatable pattern. We want to reach a result that eventually gives us fractions like such, right? Big piece, small piece, bigger piece maybe, and then that big piece is split in this way, or at least we would have a variation of noise in those edges just to make them look a tiny bit more realistic. So we will go through a couple of more workflows, and we'll see how that works altogether. Honestly, for now, I will learn a couple of those workflows, and we'll be right back with you. So one of the workflows we will work with right now is to take to get a split out of the Voronoi fracture right there. The split will look like that, and because we have chose the inner geometry and not the outer geometry, and that grouping happened before. If y'all want to see how that looks like here in Unreal, it will look something like this. Exactly. We are doing some simulation. That is the one we were working with so far. So it looks like this, and we are trying now to make those, each piece of these stones, make them look a bit more random. And yeah, we covered this now before the lunch break, and you could play with this a little bit, do some distractions. Same with here. Boom, 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 boom. And so yeah, we're doing that type of simulation, and we're looking into how different ways to do it. Okay, so let's keep doing some math magic. Good. So here we are. Now, one of the workflows, like I said, is to take the split and choose either the inside, not either or, choose the inside geometry and not the outside geometry. The outside geometry will look like this, and the inside one will look like this. Okay, so now we have split that, and we need a couple of more steps to make this work. We could either fuse it, or we could fuse it and then clean it. And now we will look into that workflow, how it works, and we'll go basically step by step. All right, stay with me. Look into that, people. So what we would need is, like I said, a cleanup, because right now this is quite dirty, in the meaning that there's a lot of overlapping geometry. This is why we need a proper cleanup on this thing. It's very, very dirty right now, so let's do it with the clean node. That's a new node that we are discovering right now. Orient polygons, or reverse winding, or fix overlaps. Fix overlaps should do it. Let's view the node itself. Yeah, that is not super good. Maybe a fuse will do the job here, so let's fuse it. Let's add tab and type fuse. Right before the cleanup, maybe we will have a good result. This is way too big of a value, of course. We can take that value upwards. All right, let me check what is done in the tutorial. We'll be right back. I think the reason why this is happening, the fuse have actually been able to successfully create the fusing, that now when you delete the overlaps, it's deleting everything with it, so to speak. Yeah. So let's try to go here, inside of here, and we will basically now go inside of the clean, and in fix overlays, we'll make sure this is checked, but not delete overlays. Overlaps, sorry, not overlays, overlaps. That's the one we need. That is the effect that is desired from now. Okay, let's see what we could do right after the step. Stay with me. I will go right back into learning some more and we'll let you know what we're learning. Here we started with the whole thing. All right, so let's check how that is done, people. Okay, so if I go into the clean here and right after I create a divide, we should be able to divide the geometry right now. We have a question. Let me read that. Okay, so let's keep going. The divide here should divide the geometry itself, and the divide now will allow, once that works, it should basically gives us more resolution to work with. Actually, one of the things that I was willing to do here is to add 200 spread, or what's it called? Yeah, scatter amount. So I could actually view what we're doing a bit better and not just like that. So let's see. We will basically now work on the adding more resolution. So if I add here, if I put this on 10, actually it's not working. Wait, if I put it on 2, it should divide again. And I think the lower the number might be. Is that the case? Or is it here? Triangulate. Wait, let's see which one it is. The divide should divide the current thing. Okay, so this is the what is the maximum amount of the edge. We have a question from TikTok. I was not expecting that. So maybe right after the divide we will add a remesh, and that is basically just straight out of the tutorial we're watching right now. And if I hook that thing into the divide now, we should be able to remesh this thing and give it not only iteration, I mean keep it to 2 now. Is there a way we could play with the actual amount of the geometry? Let's see, target, yeah, here, right there. Okay, so 0 is gonna crash Houdini. Oh no, I went there. Oh no, I went there. All right, so Control Z that, S and Control Z that. Let's go with 0.05 and see how that plays. Yeah, this looks nice. This should allow us now to add some noise, and noise can be applied with mountain node. It's also a new node. Mesh is a new node that we didn't work with. Divide is a new node. I think we worked with divide before, but remesh is definitely new, and mountain is also new. Okay, so let's hook those things up, see what the mountain does here. We have definitely some type of deformation happening. Let's see how those deformations can be. I mean, let's just see the final result when we, for example, we can't do that yet because we don't know how that structure looks like yet. So what I will do is continue watching the tutorial and I'll be right back with you. Let's go into it. Let's hop right back in. So we have options here. If we have noise along vector disabled, we will see that it will have a whole different. This is huge. This is so different. It could be cool, but for now this is way too different. Maybe it's due to the remesh being so low. Let's try. I mean, it doesn't seem to be like it. All right, so let's keep it off for now and remember where we turned it on. If we fail later, we fail. Clean, in the clean, we will enable or disable manifold geometry. Let's see what that does. Manifold geometry, I wonder what it means. Manifold and only topology. Sorry, manifold only topology. Let me read about that. So definitely we have huge values in the mountain here. And we need those to be a bit more chill. So in the amplitude, we could reduce it and you could see this effect happens, right? So we only need a little bit of that. And I can see that the remesh value we changed is now affecting our quality. So we're just going to give it a little bit more division. And then we'll go to the mountain here. And basically now play around with a couple of values. So let's see what the element, what is it called, noise pattern. Here we go. That is the type of stuff we need to play with. The smaller the pattern, the more it will, the more randomization we will get, because basically you are scaling the texture of that noise to smaller and bigger, and this is what is happening right now. And so we will basically, we've done that. What we will do now is offset. This should just give it a different seed, but I love that effect because it looks like fire. Okay, so what we will do, we have definitely changed the amplitude. We could put this a bit lower, even lower, so 1.3 to maybe even 1.05, so 0.05. And here we start to see the geometry again, thankfully. This is not so bad, but I think we can go a bit higher, so 0.08 maybe. Let's see, 0.0, I don't know, like 10. Would that look good? It is good. It's too structured somehow for me. So 3. Let's see. Let's take the noise, scale it a bit more or less. Yeah, this is way more randomized now. I quite like that actually. All right, so let's see what that does now as we keep going. That's quite awesome. We finally know our last step here, and we will go through it and see if it actually works. Honestly, we still don't know. So we kind of need this now to do an operation in order for it to go back to that cube that we started with, right? So we first need the cube that we started with. That's a way to think about it. So null. We have our, oops, nope. All right, so we need our null here. Here we go. That null will be our box. Good. So box, and we'll take that box all the way down there, and we will put that box next to mountain. And now we should find the node that brings them together, and the node that brings them together is fracture boolean. So fracture boolean, boolean fracture, here it is. Click here and you should be able to have that boolean fracture. Now let's check our inputs. We have required cutting surface and we have required geometry to fracture. So required geometry to fracture is basically our box. That is our base that we want to fracture from. And now we put our mountain in here and this should fracture it for us. If I zoom in here, we have definitely more fractures, but what we also notice is that it is not consistent at all. It's not hooking in every part of it. One way to avoid this, I suppose, is if I add transform here and I scale it just a little bit, we should be able to have that happen now. And we see that we have a way more randomized solution for our fractures. This actually looks pretty good. Let's explode it. So how to explode that? We will need an exploded view. In the exploded view, if I hook this thing up in here, we should be able to play with the scale and see things actually exploding. Now I can see already that this is not working to 100%. Not a big deal though, because I think there are a couple of more steps that we need. Oh, thanks for the follow, my friend. Appreciate it. Anyway, there should be more stuff that we still need to do in order for this to explode the way we want it to do. We want it to explode, right? So let's check how that is done. Definitely. Okay, so how is that done? Let me check, and maybe it is in the Boolean fracture operation itself. If I have an interior cusp angle, maybe this one could change some stuff for us. For now, that is not changing anything. Exterior cusp angle also not changing anything for us. Well, we have to learn that, and in order to learn that, we have to go back into the learning. Okay, you guys. So what we've done here is that first we've added a transform, but that's not the procedural way to do things, because a transform will not take the actual cube and see how, you know, and just keep track of that. So the way to do it is, this is our box, right? If I add a bound here, and the bound, what it does, it basically just takes the same shape, and now we could inflate it. We can add a padding on it, just like the word padding, right? So if I add a 0.7, for example, on the x-axis, we will see that it's gonna go this way, and if I refer it to the box just as a template, we see this white line right there. That's where the original box is. So if I add a little bit of padding in on each and every axis here, the lower one, the upper one, right? So let's do that. 0.5, 0.5, 0.5, 0.5, 0.5, 0.5. Now we have this huge padding, so to speak. And if I enable wireframe, we see how much bigger this is from the original box. And now what happens next and after that step is if I hook that value now to something called match size, we should be able to have that size matched here. So match size with the mountain, and then hook that thing in there. And this should now automatically bound, or basically, wait, why is this hooked twice? All right, so let's leave it. Let's leave this here to for us to be able to visualize things a bit better. We will basically now have a mountain here, and we have the match site for the bounding box, for the bounds. And this now should have that size in mind. And let's see how that looks like at the end. It's too big. Okay, I must have missed something here. Let me try to think about it. I think we don't need that bound to be the original geometry that we want to exclude from using the Boolean. But we definitely need the things to be a bit bigger. The things meaning those mountain, these fractions, and let's see what happens once it's in match size. Bro, how are you good at this? That's a good... We solved this while we were talking with the chat. That's quite cool, actually. I just mixed... I thought, like, why the hell was I seeing the cube here? And then, boom, I just switched those. Put this in here and this in here. And the match size is actually making it bigger than usual, I think. We just have to play with the amplitude here, I think. But then when I put it in the Boolean fracture, it's actually cutting it through the cube, which is not entirely correct. Not at all. But we'll see how we could actually... Ooh, damn, look at that. This is so cool, though. I would love to keep that. Wait, let's make the explosion happen. Are you ready, guys? Are you ready? Exploded view, and it's pretty cool. I really like that effect. But I think we're getting our data from a wrong position. Oh, it looks pretty cool, right? Yeah, that looks pretty cool. But I don't think that's performance friendly, honestly. So yeah, we will check. Yeah, the devs updated the game and added stronger protection for hacks. I see. Anyway, I'm gonna go now. You get a follow though. Thank you so much, my friend, and I see you later. Thank you so much. Appreciate you, Unk. All right, so let's keep it going then. Pretty much like that effect here. It's like I really like it. This is why they use Houdini for effects. This is pretty cool. Okay, let's learn some more, people. We'll be right back. Okay, so here we go. Let's learn what the next step is. Next step. Actually, I just saw that the Facebook Live was pretty successful. I wish I was able to figure out a way. I mean, you know what we should do right now? I'll pause the video. I think I figured it out. So the amplitude was going pretty insane, I would say. Like it was around here. We didn't want that, right? We wanted to be a little bit chill, like around here. And now let's see the next step. Okay, so we are looking at the match size. That's pretty good though. So Boolean fracture, that one should do the fracturing method. And now we'll check now the explode and make it explode. It's not taking each part. And I'm wondering now, I'm wondering if we did our cleaning properly. So what happens if I take this out? Here you go. Here you go. That's the type of result I'm looking for. That looks pretty good. Let's see, what else do we need? What happens if I remove this? That's pretty good though until now. Let's see. Let's go back into our explosion and bring that value backwards. We see that things from the inside are exploding. That could be due to the actual cut at the end not being big enough, so the bound box could go a bit bigger maybe. So 0.7, 0.7, 0.7, and 0.7, and 0.7, and 0.7. Funny how some of them worked and others just didn't work. Now I'm trying to wonder if the original box here is doing some shenanigans with the whole thing. And if I should just break that connection, bypass this thing here, and basically break this here, and see what type of result do we get. Yeah, we get the result that we kind of want from this thing, but we're still not fracturing. You know what? Maybe the bounds are maybe the bounds are too big enough. So let's try 0, 2, 0, 2, and 0 0.2, 0 0.2, 0 0.2, and 0 0.2 here. I mean, we see some holes, but it's not going pretty well here. So maybe just 0.4. Let's see 0.4 here, everywhere 0.4. And again here, and here, and here as well. How does that look like? Yeah, that is not completely good, I would say. Match size, how does it look like in comparison to the mount? I mean, is the problem here the actual amplitude? Let's check if that's the problem. So amplitude, yeah, okay, so that's the 0 amplitude. We see an actual cutting through the geometry. Let's try 0.1. Now we're getting those weird effects. Maybe they're also getting the same effects in there as well in the course. Let's get the scatter amount down to 100. Let's go back to 0 here, and we see the actual fracture getting a shape, the proper shape that it needs to be, but I just would like a simple randomization of that. But we're not getting that. Maybe the bound box is too small now. So let's go back to 7. It's funny when I go back to 7 in those numbers, we get like a really cool effect, honestly. But it's only happening on one side. That's due to the lower padding. And here as well, let's check it out. 0.7, 0.7, but then we're back to this weird result, and it's not pretty good. Yeah, we need to figure out what the problem is. So I need to go back into watching. So we'll pause that. I have definitely missed a point, and that is consolidate points. It says here, consolidate points. And if I check it, what type of operations do we get at the end? Is it any different? Does it make any difference here? I don't know yet. So let's keep learning, and we'll be right back with. All right, so we're getting to the main reason why this is happening slowly. Sorry. So if I go to the mountain, I remember disabling noise. The noise along vector, which created those weird artifacts. Let's see if we enable it. What would happen now? Does it still have the same problems, for example? And we're getting different types of problems, actually. It's a similar effect you see in animation here. It's pretty cool, but we're looking into something consistent, but this is not giving us this. It's not giving us that. So let's see what the problem is mainly here. Mountain. That mountain is not really, this is not helping us much. Yeah, must be somewhere else the problem. We'll be right back. So I basically one node, one checkbox have messed with our results. I was expecting it to actually work out of the box, but it hadn't. So we'll look into that now. So let's do it. Let's look into it right now. So we will go into the match size right there, and what we needed to check is the scale to fit. And now if you enable scale to fit, it should make it scale to fit. Here we go. And now it's going way too big and way too huge. So what we will do is go to the bound and hey, yo, you need to be 0.3, my friend, 0.3, my friend, 0.3, my friend, and the rest goes just like that. We're just making it 0.3 bigger in all the axes. So let's check that. And this is the Boolean, and it's happening right there. And you see it happening now. It's actually working. It's working pretty well. That's exactly the thing that I thought why this thing did not work. So now we actually have it. That is awesome. We have figured it out. That's so cool that we figured it out, people. Now what I would like to try is go into our mountain, which is the noise, and just take that amplitude now, let's say 0.01, and just boom, increase it slowly, and we see the different types of explosions we're getting, or fractions we're getting, and just allow it to explode now a bit bigger. Look at that thing. Look how random that thing is. That is awesome, guys. That is exactly what we need. This could make a cool like noise for like if you hook it with music, right? And it plays like that. We're already creating things for production. Here we go. So you just hook it to the loudness of some bass or some bass. So I don't know what it's called, and just it dances with the music. Yeah, that's pretty cool. I like this. And you know, it can go, the thing is, if you're rendering this, it doesn't matter like how long it will take. You could keep messing with the amplitude here and make it into a higher value as it's exploding, and you could hook one sound effect into one and the other into the other. But look at those details. This type of fraction is just awesome. This is so cool. This is exactly the type of stuff I like to do. Oh, sorry. No, please don't. Oh my God. Esk. Damn. Look how detailed those are. We're just going to go Control Z with this thing. It's pretty cool until now. Okay, so we will do some organization, and this is pretty good. It's working for us. So now we understand the process. Basically, it's divided into two things. We have the Boolean fracture, right? And we have the generation of those planes or of those plates. So we will do two subnetworks now. Subnetwork 1 will be called gen plates, cutting plates, let's call them cutting plates. Here we go. And the gen should be calculations. So just allow me to make this a bit bigger again and just have more space generally. And now this is doing the gen cutting plates. The next one will be the Boolean fracture operation. Oh, sorry, in the subnetwork. We're gonna make a subnetwork. So let's just add a subnetwork. I will call that subnetwork Boolean fracture. Here we go. Boolean fracture with a space, like we did the rest. And this is an operation. Operation Boolean fracture. Generating is, I think I put the color purple for generating. I'm not sure though. And for operations, let's take the color yellow. Good. All right, so those two things will happen one right after the other. Let's see how the actual hierarchy is done, but we could also guess it, because if this thing is going into the split first, so our generating cutting plates is going, it ends by the mountain, right? This is our cutting plates generation. So we could hook it up to this split actually. We can hook that into the first one. Now let's see the next one. we will probably start with the mesh size here. That is when we're doing the Boolean fracture operation. So let's take our Boolean fracture operation and put it like here. And now we start checking where this line is coming from. It's coming through the split. It is our first line. And the second line is our geometry, original geometry, which is the actual box. So we'll put that here maybe. And now we'll hook it up into the second input. And yeah, okay. So what I made, my mistake here is that I took this from the actual Voronoi, and I should have taken it actually from the output of the plates, because it will be working with the plates right after they're done. We will work with them right after. Okay, good stuff so far. We're learning a lot actually. That's pretty cool that I can just group those things. And next step is that we will start, I will probably cut, but I could also copy. Just now at a guessing, I will copy this operation here in our Boolean fracture. Just gonna put those things here and gonna take everything that happened. Actually, the bound is part of that, honestly. So bound goes in here too, and that bound goes into the left part, I remember. If I remember. Not into the right part. Well, I wish I could do that. Let's see. Right part, and the other part should be the other part. Okay, good. Now we will take those with the split, honestly. Let's just copy them for now. Let's not cut anything yet. I will put that operation right there. Okay, cool stuff so far. I'll be right back, people. I'll pause and so far the documentation continues. We have cleaned this up, people. We have put all of those nodes inside of here into one, and all of those nodes we have put into here. One is called generation of the cutting plates, and if I view that, we see our cutting plates. Then the next one is called operation Boolean fracture, which should give us the operation Boolean fracture, which will give us this effect with... I'm just viewing the effect. If it will give us a different effect, the actual effect it's giving us is this one right before the explosion. This one. This is the actual effect it should be giving us right after that. Now, let's see how we can improve on that and add more stuff and maybe, you know, get this thing in Unreal and make it do some cool stuff for us. So yeah. Let's definitely check that out. All right, so I will pause the recording step by step. So basically what we want to create now eventually is a system that could make the cuts happen on any type of object. So far I understand this, it should do it like this. So for now, our box will be the main target group for that. How do we do this? All right, let me show you. We will need a loop. So for each connected pieces, boom, here we go. Now we have a connectivity, we have for each begin and for each end, like we had before. And if we click on the for each begin right there, and we basically add a meta import node, which we will use now later, but not the same way we used it before for the iteration. We'll actually do it for something different. That something will be fetch input, and that fetch input will be connected right now to our cutting of the plate. So the plates.cut will be hooked to this thing. And not to mistake them, I'm just gonna put those things a bit different. The connection here will make it different. So you see that this thing is going from the box in, and this thing is going from the gen cutting plates. All right, so far that is clear. What are we gonna do with this? I'm glad you asked. We'll start with the VDB for a beginning to basically try to unionize any type of object, and we'll show you how we're gonna work with that. So VDB, the first one from Polygon. So we'll take the polygons and convert, basically make a VDB out of it, and we will see what type of value this will give us. We'll see just a normal cube here, and we will manipulate this bar until we're satisfied with the results. Maybe 0.05 for now, and then we will convert it like we did before with the other operations. So we will add a VDP convert. Oh, whoa, what is that? We don't need that. Wait a second, P, we don't need that. Okay, so tab VDP convert. Here we go, convert points. And now we will hook that thing in there. And let's check it out. We will probably, wait, let's keep it as a template, honestly. And that convert now will basically do point per voxel, and we'll put that thing lower, maybe even lower. Not sure. Maybe that low, maybe a bit higher. Okay, let me check what this actually means. I'll be right back. Oh, that is what I was missing here. We haven't actually worked with... someone just followed though. Thank you for the follow, my friend. Appreciate it. So what I wanted to say, I lost track a little bit, is convert VDB points is the wrong type of node. We don't need that. So let's go again. VDP convert and check convert VDP points. Let's see. Is that the one? No. Okay, let's check the other one. Convert VDP. Yeah, this one. This is the one we need. It should just take our VDP and convert it to points, basically, and we will tell it to do that right now to polygons right there, and this should convert it now for us. If we view it, we finally see the actual geometry again. So basically what we've done here in that process is that we're now taking whatever geometry comes, either box or column or car or a mountain or a wooden piece, and we are trying to generalize it and give it a certain amount of polygons that are equal, and then we will apply the cuts on it, and this will allow us now to work on different types of geometry. So far I understand that, and this will allow us now to do different types of stuff. All right, so let's check it together. Recording. Okay, so now we need a value that actually inflates the object, and we need the cuts to inflate with it. And the one that we will use is called VDB shaped. Okay, so let's take that thing into consideration. So VDP shaped. All right, so where's the shaped? Shape. Is that S? Wait, where? All right, VDP. Is it shape or reshaped? Sorry, excuse me. So we're just gonna add VDB. All right, let's just look for reshape here, and here we'll see it. VDP reshape SDF. We'll put it between the VDB polygon before the convert, basically, and we'll hook it up. Here we are, we have it hooked, and in here we could allow it to have an offset. If we give it an offset of 8, it will be 8, and how to say, not 8 times bigger, but like it will be basically multiplying by 8 or multiplying by 10. And for now, let's keep it on 8. And if I may show you the result after the sorry, so this is the actual VDP that is happening, right? And if I go into the VDB convert, we will see the actual work of converting that into a polygon again, which is pretty cool. Pretty neat. Good. So now we are allowing that to inflate, right? And we are dividing it. And now what we could work with is hooking this thing, which is our cutting geometry, into that, and then somehow it will follow how big it is, and it will cut it as well. So that's pretty cool. We're gonna check that out. Good. Let's pause. Okay, so I'm gonna go a bit risky here because I will do this on my own now. And let me check how to do that. So first of all, what we will be doing here is that we'll take the for each begin, which has its data from the gen cutting plates, right? And we will apply a certain group on that. So the group will group the points that are inside the box. And now we will hook that into a bounding, so in a bounding way. All right, so let me show you how that works. My understanding of it is still vague. So basically we'll take the input of the cutting edges, putting it here, and then we will take the input of the VDB reshape or the convert itself. We'll put it on the bounding object. And let's see how that looks like if I change it to points. And we view that. We see that all the points that are basically inside of that box are being grouped. If I, too, add a transformation now, and hook it right before it and give this transformation up to 10, we will see with the W that it should keep its, well, let me check. It should keep the selection inside of the bounding box, and we haven't hooked that up yet, so let me do that for us. Bounding object right there. All right, so now we only have the points inside of the box selected. Why do we need that? We need it for the bounding fracture. So we need all this type of operations to be automatically like that. It needs to be procedural. That's the point of the whole thing. Okay, so now we have that. Let's continue into understanding how to make this box, or how to make that actual transformation happen automatically so it changes with the actual scale of the geometry we will import. So that's number one. And number two, we need it to get at least a bit bigger than it. That is why we are using the bound. And now we will see how the bound would connect inside of this node tree here. All right, so let's delete the transform. Let's get the bound. Where's the bound? Bound, here you are. Bounding. The bound is right here, and the match size is right here. So the match size should be the one that is creating all this stuff here for our cutting geometry. I believe the way we hook that up properly is to actually take it right out of the match size and put it inside here. And this should now give us the bound value, so the bigger value, and we should be able to compare it now. If I view it here and I template this one, we only need to give the bound value a bigger one. So if I say 0.7 on all the axes, right? 0.7, 0.7, and 0.7, we have a much bigger cutting edge, and it's only actually grouping what is on the inside. So far, that's awesome. It's a cool system that works, and we'll see how we can take this a bit further and yeah, check how we could do it. All right, so let me pause and let's get this thing going. So far we need, all what we need so far is the actual Boolean fracture. So let's check if that has created any proper fractions. So let's hook this up here and this up here, and just for the sake of visualization, we will get our exploded view and put it in here and hook it to the proper inputs, and we'll take this thing a bit down, and just to see if we have created something solid here, we'll disable the frame here, the other thing that we had on, and we'll try to see our exploded view. Looks pretty neat. This looks pretty good. Here you go. And it goes down and boosh. Imagine like an AirPod case that is just getting exploded like that. How cool is this? It's pretty cool, isn't it? Yeah, I quite like that. Okay, so let's see what else to do in here. Now we've inflated that thing. I don't think we want it to be inflated as such. I think that is a bit too inflated, honestly. So if I choose to explode this one, right? I don't know if this would keep the inflation. If we should keep the inflation, for example, if we import a column or anything else, if we want that certain inflation to happen. But then we'll have all our geometry looking, have those like smooth edges, and I think we don't need that. Okay, let's check. So let's go back to it. I think we definitely need some type of, we don't need this exploded view, definitely, we don't need that. But what we would need here is to hook our Boolean fracture where it should be hooked, which is the for each end loop right there. And then we would need that to basically, let me see, what do we need? We need a compiler now. Let's add a compiler, but before we learned that we could add D, and then go to our parameter badges, or like right here, non-compatible SOP badge, and that one we need to be on large right there. Okay, and now this thing is exploding as you see here. That's awesome. And we will add a compile. And compile, where's it called? Compile, where's it? Compile block, that is the one we need. And now we will hook it up, and just to have the performance better. So the first one, the begin, so this is the end. The end is pretty easy to hook. That's the end, done. Now the begin is the one that needs a bit of focus, and so we'll put it right before the connectivity. And we'll add another one actually, and we'll add it here. All right, this is awesome. So we have this all in a compiled block. And now we need to find our output. Our output is right there. Our output doesn't need those values. It needs our new value, and this should make it work. Just fracture it. That's all. We don't need any exploded for now, any exploded view or whatever. We need it to just stay like it is. All right, so let's pause. Let's continue. I think I've answered that. I've basically found out now in the course they have a different value than here. I have like this AirPod case thingy here happening, and I think there's a value we can add to the convert or to the reshape that could change the way this looks. Let's go with open maybe, or with a close, and we are getting closer to the result we need. So let's see with the different types. First order unwinding, second order rending, appending. Well, let's see what happens if we change it. All right, that's good. Let's go with the fifth. And almost there, honestly. Maybe there's a different solution to this. Trim all, trim exterior. Trim interior, trim none. And let's take the first. We're almost there. Let's go with delete, erode, open, and close. Okay, let me check what is the exact setting for this, and we'll be right back. So that was pretty simplish to fix. We have definitely forgot to delete what comes after the group, just because I'm so distracted. So here's the group, right? We created that group in the W. It's only what's the inside, and we will delete what's on the outside. So how to do that? We will promote our point group. So this will be cutters here. Let's name that. Those are cutters inside group, but it's a point group. We need to change it into primitive so we can delete those. So let's go into promote, group promote. Here we go. And the promotion now will go from points to primitives. Okay, and this type of group will be called cutters inside. So it will start from the cutters primitive selection to the cutters. Wait, what happened here? Why did we have those? All right, I think that's why. Cutters inside, and that is a primitive. And primitive is important for proceduralism, so far I understand. Okay, so good. Let's keep going. This thing should be hooked into a blast, but not last. Here we go, blast. We should delete all this group, but not the group. All right, so inside, what do we have in here? Here, cutters. Cutters inside. Wait, where can't we? Wait, we should change it. How to do that? Let me try to think. So delete non-selected first of all. And in the grouping, we should be able to see our primitive grouping. Cutters, wait a second, something is wrong here. Points, cutters inside points, fine for me. Then we have a problem here, let's check it out. No group match pattern. Okay, so yeah, there's something definitely wrong in here. We'll check how to solve that. I honestly think it's, instead of choosing this one, we need to go all the way down to cutters inside points. And we delete all of this. And then again, scroll down to cutters inside points. Here you go. Now we're selected. Now we have it promoted to a primitive. And now we should be able to see it inside of here. And we will delete a non-selected, don't forget, because we only need to delete what's on the outside. Not what's on the inside, but what's on the outside, like right here. And then we would basically apply our Boolean fracture, but our input right now is in the convert VDP. The convert, all of those two operations are happening just so we can have a proper sizing for the cutters. So what I'll do is put those in the middle so I could see that it's actually separated. And this one too, it's actually part of it. So what we'll do is just take our box, our bar, where is that? No, that is our box. We'll take our box input that is hooked inside of our connectivity into the loop, into the compiler, into the loop, and that thing should be hooked right into the Boolean fracture now. And this is how we could keep our shape, right? Keep our shape. We don't want it to change. And yeah, this should explode it pretty well. If I to explode this, it should explode pretty well. I can see that we are having a bit of issues with the blast now, because it basically had blasted a bit too. We probably still need a bit of sizing in there, so we need one more operation to make this happen, like a bit of like a couple of values more. Let's see if we could take our bound, honestly, our bound value, which comes right inside of it. Let's take the null of that, so null, and take that down here, maybe down here, and right after the blast we want it to just get a bit bigger. Does this work? Is this taking the current value and taking it to... No, it's not. Oh man. Okay, let's see. For now we have the fracture, but it has some problems, I could see. Let's see if we are correct with those things. I mean, it is going beyond, above and beyond. Maybe that is happening due to the actual noise in the mountain, the thing we've added. So let me go inside of here. We're getting inside of our node again. Let's make everything bigger a little bit again. And let's go to the generation cutting plates. Let's take the plates here and take our go inside of it and just change our mountain value in the alt amplitude. So let's take that into the 15, maybe something even less than that, so 13. All right, this should work for now. Go back inside of... All right, let's stay here. That's fine, though. Let's check our values inside of here in the other node that we created. And let's see. Okay, let's close our colors for now and check our Boolean fracture and the exploded view. Let's see our exploded view. What do we have in here? We have a lot of weird artifacts, but how can I change that anyway? Maybe it's too big. Maybe it's too big and reshape. Let's go back to 5. Does that change anything? 3? Not much. Yeah, since we've added the actual deletion, the blast, this had happened. Yeah, exactly. Yeah, I don't know if the blast would make sense here, honestly. We'll keep it now without the blast. And yeah, just keep it like this for now. That's fine, I guess. We'll be right back into it again, and maybe we could change the blast here. All right, so this thing is not important. Let's just keep going into the compile and view if that is applying those changes, and it actually does. That's pretty well. All right, so let me pause and learn. I think I might have an idea now why this is actually happening. Okay, so one of the reasons is, so if I go into the blast here and I view the actual where is it? The actual grouping is right there. And if I reference it with the conversion and I press W, we see that the problem could be happening due to lack of remeshing or points in there. So it's cutting those and it doesn't have precision of cutting them. This is why we're getting that problem, in my opinion. That is my current understanding. So in the remesh here, let's go with something more conservative of 0.01, 0.01, yeah, let's see. How much polygons are we talking if we do this right now? Let's see. It's gonna lag. Yeah, that's a lot of, that's a lot of polygons. Let's go with something a bit more, and we should get a less triangles, and we will wait. We have all day, doesn't matter. We are waiting. Okay, so I think it's done. Okay, and now I go back into our grouping and we should see better simulation here, or better accuracy. If we don't, let's just put this into 0.02 just in case, and now we should have better accuracy. Once that is blasted, however, we will see that this here is yet still to be shown, that it's still in its box, but in comparison to the actual box in here, let's put that as a template, this box is still big. Why is that though? So let me do an experiment a little bit with our reshape. I think our reshape is not doing what we wanted to do. This is doing what we wanted to do approximately. So I think when we change this to, let's trim all, that's fine. I think when we change it to close, it was very, 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 very small. It didn't reshape it, basically, almost. So now when we have blasted things and we look at it, actually this might force us now to regroup things and put this thing a little bit smaller into like the 5s. And this will go now into the blast again. Let's check our deletion. Yeah, this is much bigger, it's much better. Let's check our Boolean fraction now again. No more artifacts, correct? And the actual explosion looks pretty neat now. Yeah. And let's save it, because if we don't save, we might lose progress. So 3.1 for now. 3.1. Week 3.1. And let's add some. Let's go back to our HDA in the week 3. Click on this thing. And let's give this thing a little bit more scatter. So scatter amount, let's go with 200. Let's go with 500, honestly, and see how that will affect the general look. Here we are in the exploded view. We'll go back there. Look at that thing. It's looking pretty neat. It has more details. Let's go back with 1,000 scatters and wait a little bit. And then we should have more breaking points inside of here. Wait for it, and here it is. So if I take that uniform scale, the thing is exploding pretty neatly. However, I can still see that it's very much uniformal, and I will try to solve that a little bit with going inside of our DGA. I would like our shapes to be more random, and I think one way to do that could be by changing the altitude of the actual mountain. So let's go with something more less conservative with like 30. Yeah, this is very weird. I like weird, so let's check here. Let's check if this would work and if it would still give us the explosion we want, or a better one for that matter. So yeah, let's check that, and we're going inside of it, and it's loading. It's normal to load. A lot of calculations are happening, definitely, and it's doing them right here in the bottom. That's pretty cool, guys. That's a lot though, with 1,000 scatter. But yeah, now it's a bit like glass, right? So let's take the explosion. Here we go. That's awesome. Yeah, that's pretty cool. I like that. It's very random. It's glass, basically, what it is. So we need something less. It's not completely glass, because glass has like those network type of deal. But it's cool. I like it. But we can't use it, unfortunately. So we have to put, first of all, our scatter amount to something less, but I mean, now we could wait, it doesn't matter. So let's put this back to 22 for now. Press enter, let it cook, and we'll be ready. Okay, that is very interesting right now. We will attempt it. We'll attempt to do it. But this is so far, yeah, okay, good. The only thing that will be a problem are those small pieces. So we will basically follow the tutorial, the workshop, and see how we could get rid of those. Well, before I go run into so many issues, I will go back into the hierarchy. Actually, one more up. Let's just press escape for now. Let's go back here. This is too much. Let's make it into 200 for now. Good for me. Let's go inside of our... let's go inside of here. Let's go inside of... All right, so now we need to take whatever values that we got from our Boolean fracture, and we start to make a new subnetwork in here. And we need that subnetwork to basically... Let's hide this. That's fine. Let's hide this. Go back here and make this a bit bigger. Okay, so we make this subnetwork, call it delete small pieces. All right. This delete small pieces, it's an operation actually, so we'll just say op and make it also yellow. Just click on it and click yellow. YOLO. No, not that yellow, the other yellow. Good. All right, so now in here we will start deleting those small pieces one by one. Okay, so let's see how to do this the easiest way. One of the ways you could do it is by adding delete small pieces. Okay, so if I add this here now, with its margin, you could see it's deleting those pieces. And if I take that threshold in this 0.01 and I take it upwards, it's deleting bigger pieces. And the smaller... All right, so here you go. So what can we do with this operation? We could take that operation, copy it twice, actually copy it with reference. So copy, how to do it? Duplicate with reference, show node information, view dependency, edit comment, let's see, parameters and channel, create nested channel groups, dive into network actions, use default color, how to do a copy reference. All right, let's go one by one. Show in asset manager, digital asset. No, that's not the stuff we want. Edit extra sections, allow editing of contents, help, output, input, save, edit comments, view dependency, show node information, spreadsheet, preview window, parameters and channels, create nested channel groups, add it to channel list dialog. Where's that thing? Dive into network or actions, use default color, use default collapse to subnetwork, extract contents, create reference copy right there. Actions, create reference copy. And this should create for us a reference copy for now. This reference copy, we should be able now to do different stuff with them. Let's delete the output of them. and we could, in the reference copy that we just created, flip the whole thing. So Shift Control Click, I think, to be able to do some things without the reference. And this will take the other value. And now we will see what what type of cool stuff we could do with this. This is kind of pretty cool here. All right, so we took the delete small pieces and we copied the reference from it, and we made it we made it flip, and now we will pack things. So pack. Here we go. We will pack this stuff here. We will just check how many pieces are those. Let's add the name attribute. Let's check the pieces, 69, and another pack. Here we go. Boom, done. And let's take our name attribute. And how many do we have here? 1794. Okay. Now let me check what we could do next. So I think I get it. I think I get it a little bit better now. Okay, so we have... we're working with the name attributes, right? We've enabled that, and if I disable it, it will look completely different. It will just be 1.1 primitive. It packed everything into one. And since we're working with the same name here, we can basically transform attributes. So not only use it, but also transfer the attributes, the name attribute right there. We've done this with the other pack before. And so now we could pass it, we could transfer the information. And if I add a transform attribute, I think, actually it's called attribute transfer. Okay, so just transfer, let's look for it together. Attribute transfer right there. And if I put this one here and this one here, and I view now whatever comes out of that, and we, on checkpoints, we just stay with the name primitive, we should be able to see... I'm getting a different result. I think we should also add the name here. Destination group, source group, maybe? Okay, give me a second. I get it. Missed one tick box into the delete small part, and that's due to the gap of knowledge. Actually, it is on area. Now wondering, should I put this something lower? Maybe, and now we can get some results. Do I make this invert and the other one not invert? And this could work now. I think so. Not completely sure though, if it's working for us or not. We'll be right back. Okay, I think the key to understand what is happening in the attribute transfer here, if I check the geometry to transfer attributes from input here, if I just try to understand the inputs, this says geometry to transfer attributes to input 1. Geometry to transfer inputs, to transfer attributes from input 2. This is from and this is to. Alright, this is to and this is from. So it's taking the attributes from this, which are 233 points, and it looks like that. So it's taking the attributes from here, the name attributes, it's transferring it to this one, and it's taking the actual numbers inside of here, the actual result inside of it. And so if I have this one, it has 1,640 primitives, and this one has 223 primitives, and we are transferring the name attribute from this one to this one. Now we have 1,640 attributes, primitives. And why did we do that? What's the actual purpose of this? Is it that now we have... trying to understand. What happens if... Ah, man. This is a bit complex for me. I don't get it completely. Maybe we'll get to the point where we start understanding this a bit better in the future. I'll also try to ask what it means. One prim attribute's name, string 184. and this has 223. So if I have a null here, just curious, what would that mean? Yeah, still the same primitives, but doesn't matter really about the primitives. It's about the string. So this has 223 strings, and this has 1640 strings, and now we basically have 184 strings because we transferred the attribute name to this one, and we ended up with something less, I guess. All right, so let's keep checking. We will go into the tab, and we will basically add an unpack. And this unpack will now unpack everything we've done to continue the operations on. And we will make it go between the attributes we just transformed, name, target or transfer groups, that's fine though, detail attributes. Let me check if... Okay, so far when I played it a bit slower and I repeated what he's saying, and it says what the job of this is taking the closest name attributes from the big pieces, and it's applying them on the small pieces, and this will allow them to merge forward if we take the unpack value and keep the transfer attribute name, and then we merge, right? So we merge things now. So we take the merge from the unpack, and we take the value from the small, like from our let's take it from here, from the delete small parts, so the bigger parts, and merge those two, because this is showing us the big parts, this is showing us the small parts, right? Yeah, and now we merge them together, and we exploded, so exploded view. And let's basically check it out in comparison to the old way of doing things. Shift S. And so the way to test this is just to hook the exploded into... Well, first let's play with our margin here. Let's give it a 0.05. This should delete more stuff. And let's hook this to the original. Right, wait. What do we have in here? I clicked on the stream yesterday. When you ended, compare this thing with the original input. So let's see what is the difference. Yeah, there's definitely way more smaller parts. If I do Ctrl Z, less smaller parts. And I think we have like merged them in a smart way using the attributes basically. When we have deleted the small parts here and deleted the small parts here as well, and then we packed them, and we transferred those attributes into attribute transfer. Now they have the name attribute from this one, the bigger part, into the smaller part. So it's taking the closest points. It's taking it from 1,774 strings to 83 strings. This is how much data, how much merging we're doing here with the attribute transfer. And then we unpack them again, just normal. So we're ending up with lesser points than we started with, I believe. We have 75,000 points we started with. When we unpack, we have 33,000. In the merge, we have 75. That's good still. But basically, we're deleting the small parts by merging them. It's a smart way to delete things. Let me just add a note here to actually remember what this done. Deleted the smaller parts with merging them in a smart way, with the attributes, so attributes, with the attribute name. Good. Let's keep that note here. We've merged them. Let's play a little bit with the value from the delete small pieces, and let's see if more small pieces get deleted, the higher we go, yeah, more stuff got merged, that's for sure. Let's just compare it to the normal output if we explode it. Wait a second. How to take it? We just take like, let's take the output, put it into a null just to have the ability to test things fast. All right, so what is the difference? For now, there's not much difference. It's like we need a smaller value in order for this to work. So 0.01. All right, and now we basically hook this up here and we see the differences. Yeah. Let's go into a smaller value even. Is that possible? Maybe we go 0.001. And do we have, is it more accurate is the question now? Yeah, that's weird though. Can we do a 2? What would that affect? I have no idea. I think it's due to the shape that we're not, yeah, 0.1 is pretty huge difference. Yeah, that's good. All right, we'll pause for now. Let's make things go into the output and let's see how that plays out. Let's actually not add the exploded vision here. Let's just keep it as it is. And now we could see the work that we've done if there are small pieces. Let's see if, let's play with that value a little bit and check our small pieces. Higher, higher, lower. It's not visible from here. I think it's due to the fact that most of the work is being done inside and not on the surface. We might be able to go get less of those weird artifacts if we go with a more conservative number, like 0.15 or 0.13. Maybe even less with the mountain noise. Let's go with 10. Okay, this is fine. If we go back now here, into the deletion of the small pieces, we check our explosion value. Yeah, now it's less small pieces for sure. And what happens if I hook it up to the normal one? We have small pieces. Exactly, that's exactly what we're trying to do here. No small pieces. Small pieces. All right, let's look at it from far though. Let's look at the input. Yeah, no small pieces, small pieces. Good. That is looking good so far. Let's save and learn some more. Actually, we're done for today. Good. Yeah. If you enjoyed the stream, and it's too late, it's too early on your place, it's too late in my place. Check the YouTube videos. They are super cut and they don't cost you as much time. Anyway, if you're wondering how we came to this level, for now, I will say bye and thank you all for watching, and I will see you tomorrow. And bye.